Hi, welcome to Mechatronics Lab. Today I am going to demonstrate about computer clock. The computer clock is simple oscillator circuit gives continuous square wave pulses at precise rate of time. What is the square wave pulses? This is simple square wave diagram. The square wave continuously oscillate from 0 to 5 volts. In simple words, logic 0 to logic high. And see here single pulse square wave. Single pulse square wave single pulse square wave diagram. This is on time, this is off time, and also on time means logic 1, off time means logic 0, and also on time equal to 5 volt and off time equal to 0 volts. In the real world, a square wave is not perfectly square because of internal circuit. It cannot give perfect square wave. It slightly have a slope, and this slope is called rising edge, and this slope is called falling edge. The rising edge means goes from 0 to 5 volts. The falling edge goes from 5 volt to 0 volts. This edge timing is most important in the computer clock. The edge timing is rising time, falling time. This is the continuous clock pulse 1 0 1 0 1 0 1, and this is single clock pulse diagram. This is on time, this is off time. Most important is rising edge and falling edge. Most of the digital circuits working on this rising time and rising edge and falling edge. The rising time and falling time is also most important in digital circuits. Now let me show you how the rising edge and falling edge important to the digital circuit. See here, you are talking about computer clock blinking on and off, and other two shifts are wired. One is binary counter, another one is shift register. We will discuss about shift register and binary counter in future video. Okay, now come to the point. This is 4-bit binary counter, also called program counter. This binary counter counts 0 to 15 on falling edge of the clock. What is the falling edge? Let me show you what is the falling edge. See here, this is continuous clock and this is manual clock debound circuit. I will explain what is the debound circuit later. Let me show you. The LED is off, it means 0 volts and also means logic 0. When we press this button, the LED goes from 0 to 5 volts. It means logic high, also called logic 1. When we release this button, the LED goes from 5 volt to 0 volt. See here, 5 volt to 0 volt. It means falling edge. When we press this button, it comes to 0 from 5 volt. It means rising edge. And when we release this button, it goes from 5 volt to 0 volt. It means falling edge. if you clearly observe the binary counter, 1 minute, binary counter, this is 1 1 1 1. In decimal, it is equal to 15. Now concentration on I am pressing this button. Press, nothing is happened. When we press this button, nothing happened. Now I am releasing this button. Binary is changed. Because of when we release this button, the LED is going from 5 volt to 0 volt. It means falling edge. Falling edge. Then the digital circuit is triggered. Now another time. This means 4. This is fourth place. This is 4. In decimal it is 4. Now it comes to 5 1 0 1 1 0 1. It means 5. In decimal it is 5. Every time I pressing time, this nothing is happens. When we release this button, it going to trigger. See here, I am pressing again. It means 4 and it is 8. It means 12, 13, 14, 15. Now it comes to 0. Now again 1, 2. If you clearly observe the falling time, when the light is going to off, that time the circuit is triggered. Observe clearly. This means 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And another example, this is a shift register. This shift register is triggered on rising edge of the clock pulse. This binary counter triggered on falling edge. This shift register triggered on rising edge of the clock pulse. This is a clock input of this binary counter. This wire is a clock input to the shift register. This is and so on. This is input data. This is clear data, clear push button. This is input data push button. This is clock pulse push button. Now I am going to press this button. Nothing is happens. Nothing is happened because we have to enter that data. I am going to entering data by pressing this button and pressing this button 1. Again I am pressing this button 1 and pressing this clock pulses, giving clock pulses. If you observe when I press this button, the rising edge 0 to 5, another bit is coming here. See here 1 1. On falling edge means LED is going from 5 to 0 volts. Nothing is happens. When I press this button, the new data is entering to the right side of this LED. On falling edge, nothing is happens. Nothing is happen. Rising edge shift to data right side of the plug. See here, shifting the data, rising edge. Again I am pressing this button, giving clock pulses 1 1 1 0 0 0, again 1 1 1 0 0 0 0 0 0. This is a clear data push button. If I press this button, the data is clear. This is how the computer clock is most important in the digital circuits. Now I am changing the clock input from this push button to continuous clock. See here, the binary counter counts from 0 to 15 continuously. Sorry. Sorry, it has a loose connection, no problem. 3-bit binary counter. Okay, it came. And see here, shift register. I am pressing the data. If I press this button, it means 1. Sorry, I have to give a clock pulses from here to here. Okay, now I am pressing this button. 1 1 1 0 0 0. This is the all about computer clock. The computer clock like a human heartbeat to the digital electronics. Thanks for watching. Have a nice day.